Between 1978 and 1985, GM sold over 1 million diesel cars. Nearly every single one broke. That's not hyperbole, and the damage didn't just kill an engine, it killed diesel's reputation in America for decades. To understand how this engine came to exist, you have to understand the world it was born into. And that world was panicking. October 1973. The Organization of Arab Petroleum Exporting Countries announced an oil embargo against the United States. Practically overnight, the country that ran on cheap gasoline suddenly couldn't get any. Lines at gas stations stretched for blocks. Fistfights broke out at pumps. Some stations just closed entirely, hanging handwritten signs that said, "No gas today." Regular unleaded went from about 38 cents a gallon to over $1 in what felt like the blink of an eye. And that was just the beginning. By the time the Iranian Revolution hit in 1979, prices had climbed past $1.30. Adjusted for inflation, Americans were paying more for fuel than they ever had in their lives. Now here's the thing. The American auto industry in the early 70s was built on one product, big cars with big engines burning big amounts of fuel. GM was the king of this world. Cadillacs, Buicks, Oldsmobiles, Chevrolets, all rolling off assembly lines with massive V8s under the hood. Full-size sedans, station wagons the length of small boats. These things got 8, maybe 10 miles per gallon on a good day. And nobody had cared because gas was cheap until it wasn't. Washington responded in 1975 with the Corporate Average Fuel Economy Standards, CAFE for short. The law required every manufacturer to hit a fleet-wide average fuel economy target, starting at 18 miles per gallon for passenger cars in 1978 and ramping up to 27.5 miles per gallon by 1985. Missed the target, and you paid fines, massive fines, per vehicle. For GM, this was a crisis. Their entire business model depended on selling large, comfortable, profitable cars. The profit margins on a full-size Oldsmobile 98 were enormous compared to a compact. Shrinking the cars meant shrinking the margins. It also meant alienating the customers who'd been loyal to GM for decades. The people who bought Oldsmobiles and Buicks didn't want small cars. They wanted their land yachts. They just needed those land yachts to somehow use less fuel. And this is where diesel enters the picture. Diesel engines, by the nature of how they combust fuel, are roughly 30% more efficient than equivalent gasoline engines. Same size car, same weight, same comfort, but 30% better fuel economy. On paper, it was the perfect solution. You didn't have to make the cars smaller. You didn't have to sacrifice the ride quality or the trunk space or any of the things that made a GM full-size sedan a GM full-size sedan. You just swapped the engine. Mercedes-Benz had already proven the concept worked in America. Their 240D and 300D diesel sedans were selling as fast as the factory could build them. Wait lists stretched for months. American buyers who'd never considered a diesel in their lives were lining up for these things, specifically because of the fuel economy. GM executives watched those sales numbers and saw an opportunity, a big one. The decision came down from the top. Oldsmobile, GM's engineering-forward division, would develop a diesel V8 for the American market. It would go into the full-size cars first, then spread across the entire GM lineup. Buicks, Cadillacs, Chevrolets, Pontiacs, all of them would eventually get the diesel option. The plan was ambitious, hundreds of thousands of diesel-powered cars per year. GM would become the largest diesel passenger car manufacturer in the world. But there was a problem with the timeline. Designing a proper diesel engine from the ground up takes years, 5 years minimum for something production-ready, and it costs billions. GM didn't have that kind of time. CAFE deadlines were approaching fast, and every model year that passed without improvement meant fines and lost ground to the imports. So GM had the motivation, they had the market demand, they had the manufacturing capacity. What they didn't have was a diesel engine, and building one from scratch would take years and cost billions. So they took a shortcut. Here's the core problem, and it's a big one. Diesel engines and gasoline engines might look similar from the outside, but internally they operate in completely different worlds. A gasoline engine compresses its air-fuel mixture to maybe a 9-to-1 or 10-to-1 ratio, and a spark plug ignites it. Cylinder pressures during combustion run around 700 psi. That's a lot of force, but it's manageable with standard cast iron or aluminum construction. A diesel engine has no spark plugs. It compresses air alone to such an extreme ratio, usually around 22-to-1, that the air gets hot enough to ignite fuel on contact. The combustion pressures that result from this process run around 1500 psi. Some designs push even higher. That's roughly double what a gasoline engine sees. Every single combustion event, every single cylinder, thousands of times per minute. What does that mean in engineering terms? It means everything in a diesel engine needs to be stronger. The block needs thicker walls. The main bearing webs need more material. The crankshaft needs to be beefier. The connecting rods need to handle more load. And critically, the head bolts, those fasteners that clamp the cylinder head down onto the block and keep combustion gases from escaping, need to be substantially larger and stronger than anything a gasoline engine requires. Every diesel manufacturer on the planet understood this. Mercedes-Benz understood it. Their OM617 diesel, which was the benchmark at the time, used head bolts roughly 50% larger in diameter than what you'd find on a comparable gasoline engine. Mercedes also chose a 5-cylinder inline configuration, specifically because it reduced stress concentrations compared to a V layout. They designed that engine from scratch, from the ground up, as a diesel. Every dimension, every material choice, every fastener was selected for diesel duty. GM took a different approach. They looked at the existing Oldsmobile 350 cubic inch gasoline V8, an engine that had been in production for years, and said essentially, we'll make this one-burn diesel fuel. The reasoning was straightforward from a business perspective. The tooling already existed. The assembly line already existed. The workforce already knew how to build it. Designing a completely new engine from scratch would cost hundreds of millions of dollars and take years. GM wanted diesel-powered cars in showrooms by the 1978 model year. That gave the engineering team barely 2 years to make it happen. 2 years. To convert a gasoline engine into a diesel. For context, Mercedes spent the better part of a decade developing and refining the OM617 before it went into mass production. So what did GM's engineers actually change? They strengthened the block somewhat. They added glow plugs for cold starting. They modified the fuel delivery system. They increased the compression ratio. But the fundamental architecture of the engine, the bones of it, remained a gasoline engine. The block casting was not significantly reinforced around the main bearing webs where diesel loads concentrate. The bottom end was beefed up only modestly, and the head bolts. The head bolts were the same size as the gasoline engine, same 10 bolts per cylinder head, same diameter, same thread pitch. The same fasteners that were designed to contain 700 psi were now expected to hold back 1,500. That's not a marginal increase. That's asking a fastener to do double duty with zero additional capacity. Engineers on the project reportedly raised concerns about this. They knew the math didn't work. They understood that those head bolts were going to be the weak link in the entire system. Management overruled them. Redesigning the bolt pattern would have required new casting molds for the block and heads. The tooling investment alone would have run into the tens of millions. And it would have delayed the project by at least a year, probably more. GM wasn't willing to accept either cost. So what happens when you take an engine designed for 700 psi and ask it to handle 1,500? You already know the answer. But GM went ahead and built over 1 million of them anyway. The engineering was compromised from day one. The head bolts were too small, the block was too weak, and the timeline was too short. But the real story is what happened when these engines actually hit the road and ended up in the hands of everyday buyers. Because the head bolt problem was just the beginning. The launch went well. Too well, actually. When the 1978 Oldsmobile Delta 88 and 98 Regency hit dealer lots with that diesel V8 under the hood, people lined up. Over 60,000 diesel Oldsmobiles sold that first year alone. Waiting lists stretched for months. The fuel economy numbers were real. 30 or more miles per gallon on the highway from a full-size American sedan. In 1978, with gas prices climbing and memories of the fuel crisis still fresh, that was everything buyers wanted to hear. Cadillac got the engine next, then Buick, Pontiac, Chevrolet. GM was putting this diesel in everything they could, and for the first few thousand miles, owners were happy. The engine was quieter than expected. It sipped fuel. It felt like the future. Then the failures started. 10,000 miles, 15,000 miles, sometimes less. Head gaskets blowing, not occasionally, routinely. The head bolts, those 10 bolts per cylinder head that were never designed for diesel compression loads, started stretching. And when they stretched, they pulled their threads right out of the block. Once that happened, the head gasket seal was gone. Coolant poured into the cylinders, oil mixed with water. The engine was finished. But it got worse. The cracked heads and failed gaskets let coolant seep into places it should never reach, specifically the fuel system. Water contaminated the diesel fuel, and that contaminated fuel went straight into the Rusamaster injection pump, built by Stanadyne. Now, diesel injection pumps are precision instruments, tolerances measured in 10,000ths of an inch. They rely on the fuel itself for lubrication. Water in diesel fuel is a death sentence for an injection pump, and GM didn't include adequate water separators in the fuel system, so the pumps died. Replacing one cost over $1,500 in 1980 money, that's roughly $5,000 today, and they were failing at 20 to 30,000 miles. Now, picture the dealer experience. A customer pulls in with their brand new Oldsmobile or Cadillac, smoke pouring from under the hood, engine knocking like a jackhammer. The service advisor writes it up. The technician opens the hood and stares at a diesel engine he's never been trained on. These were GM dealership mechanics, gasoline guys. They knew carburetors and spark plugs and distributor caps, diesel injection systems, glow plug circuits, compression ignition diagnostics. They had nothing, no training, no specialized tools, no experience, so they guessed. And the botched repairs made everything worse. Technicians over-torqued head bolts that were already pulling threads. They replaced gaskets without checking for block damage. They put engines back together that should have been condemned. The cars came back, again and again. One case that got a lot of attention involved a 1979 Cadillac Seville diesel. The owner was a doctor in Michigan. His Seville needed 3 complete engine replacements within 40,000 miles. 3 engines, in a car that cost over $20,000. He sued GM and won. His case was one of hundreds. By 1981, warranty costs were astronomical. GM was hemorrhaging money on these engines. And they started doing something that tells you everything you need to know about how bad the situation really was. They began quietly offering gasoline engine swaps to diesel owners. GM's solution to their diesel engine was to rip it out and replace it with the gas engine they should have left in there in the first place. They'd pull the diesel, drop in a 350 gasoline V8, and send the customer on their way. It was an admission of defeat disguised as customer service. So the engines were failing, owners were furious, dealers were drowning. But to understand exactly why these engines self-destructed so reliably, we need to get into the technical details. And the engineering failures were even worse than most people realize. So that happened. If you're enjoying this, hit subscribe. We do deep dives like this every week. All right, Let's get into why this engine was basically designed to eat itself alive. The Oldsmobile 350 diesel had a compression ratio of 22.5 to 1. That's appropriate for a diesel. You need that kind of squeeze to ignite fuel without a spark plug. The problem wasn't the compression ratio. The problem was everything underneath it. Start with the head bolts. In a gasoline engine running 9 or 10 to 1 compression, the forces pushing against the cylinder head are manageable. Standard head bolts handle it fine. But at 22.5 to 1, the combustion pressures are roughly double what a gas engine produces. Every single power stroke is hammering the head bolts with forces they were never meant to handle. And these were gasoline-spec head bolts threaded into a block that was originally cast for a gasoline engine. Here's where it gets ugly. The block was cast iron, which is fine. But the thread engagement, the depth and quality of the threads those bolts screwed into, was designed for gas engine loads. Under diesel pressures, the bolts would stretch, not break. Stretch. They'd yield just slightly beyond their elastic limit, and over thousands of cycles, they'd pull the threads right out of the block, slowly, progressively, irreversibly. Once a head bolt lost its clamping force, the head gasket couldn't seal anymore. Combustion gases at over 1,000 degrees started leaking past the gasket, and that's when the real cascade began. A breached head gasket doesn't just leak exhaust, it creates a pathway between the combustion chamber and the cooling system. Coolant starts seeping into the cylinders. Now you've got antifreeze mixing with diesel fuel inside the combustion chamber. Some of it burns off, some of it doesn't. The stuff that doesn't burn washes past the piston rings and drains into the oil. But the real killer is what happens when coolant gets pushed through the fuel return system and back into the fuel supply. The injection pump on this engine was a Rusamaster DB2. It was a precision instrument. The internal clearances in that pump were measured in 10,000ths of an inch. Tolerances tighter than most people can even conceptualize. These pumps relied on the diesel fuel itself as a lubricant for their internal components. The fuel had to be clean, dry, and free of contaminants. Water destroys these pumps. Even tiny amounts cause corrosion and scoring on the internal surfaces. Coolant is worse than water because it contains glycol and additives that accelerate the damage. Once contaminated fuel reached the Rusamaster, the pump's precision surfaces would corrode, score, and lose their ability to meter fuel accurately. The engine would run rough, lose power, and eventually refuse to start. Now here's the part that really gets you. Mercedes had been building diesel passenger cars for decades by this point. Their OM617 engine included a fuel water separator as standard equipment. They also put a dashboard warning light that told the driver when the separator needed draining. Basic stuff. Diesel 101. GM initially included neither. No fuel water separator, no warning system, nothing between contaminated fuel and that precision injection pump. Every other diesel vehicle on the market had water separation. GM just skipped it. When they finally added a separator in later model years, it was a small inline unit that owners had to manually drain. They buried it in a location that was nearly impossible to access. Most owners never knew it existed, and the pump replacement was the single most expensive repair on the entire car. It was also the most common one. The main bearing webs in the block and the crankshaft itself were gasoline-grade components. They weren't built for the sustained hammering that diesel combustion delivers. Crankshaft failures happened. Bearing failures happened. The engine ran rough compared to the Mercedes diesel because the fuel injection timing was poorly calibrated and the glow plug system for cold starting was inadequate. Mercedes owners started their cars in Minnesota winters. Oldsmobile diesel owners called tow trucks. Every failure fed the next one. Head bolts stretch, gaskets fail, coolant enters fuel, injection pump dies. The engine wasn't just poorly built, it was a chain reaction waiting to happen. So the technical failures were comprehensive and interconnected. But the real damage extended far beyond just the engines themselves. The consequences for GM, for diesel technology, and for American car buyers would last for decades. So GM knew they had a problem. By late 1979, the warranty claims were piling up faster than the accountants could process them. Dealers were overwhelmed, customers were furious, and the engineers back in Pontiac, Michigan, were scrambling to fix an engine that probably should have been recalled entirely. Instead, GM did what GM always did. They made incremental improvements and hoped the problem would go away. The 1980 models got longer head bolts. That was the big fix, longer bolts that threaded deeper into the block, trying to keep those cylinder heads from lifting under combustion pressure. They also improved the head gasket design and tweaked the fuel injection timing. It helped. A little. But the fundamental problem remained. You still had a block that wasn't designed for diesel duty, still had a cooling system that couldn't handle the thermal loads, and still had an engine that was essentially allergic to the fuel it ran on. Then came 1982, and GM did something genuinely significant. They introduced the 263 cubic inch diesel V8. This wasn't just a tweaked version of the old 350. This was a substantially redesigned engine. Smaller displacement, yes, but with larger head bolts from the start, reinforced block castings, roller lifters to reduce valve train stress, and a proper fuel system with water separation built in from the factory. They improved the glow plug system so the engine would actually start in cold weather without the owner performing a ritual. The 263 was, by most accounts, a genuinely competent diesel engine. It addressed nearly every critical failure point that had plagued the 350. The engineers had done their jobs. They'd listened to the warranty data, they'd analyzed the failures, and they'd built something that actually worked. Nobody bought it. That's the painful part of this story. GM finally built a decent diesel, and the market wanted nothing to do with it. Sales of GM diesel cars had peaked at over 300,000 units in 1981. By 1983, that number had collapsed to under 60,000. By 1985, fewer than 13,000 GM diesel cars found buyers. The reputation was unsalvageable. The word diesel had become a punchline, and no amount of engineering improvement could change that. Meanwhile, the lawsuits were stacking up. Class action suits hit GM from multiple states. The Federal Trade Commission launched an investigation into whether GM had engaged in deceptive practices by selling what was essentially a converted gasoline engine as a purpose-built diesel. GM's response was expensive. They offered extended warranties stretching to 120 months or 100,000 miles. For the most problematic early models, GM offered something almost unheard of: free gasoline engine conversions. They would literally rip the diesel out of your car and drop in a gas engine at no charge. The manufacturer was admitting, without quite saying it out loud, that the engine couldn't be fixed. It could only be replaced. The total cost to GM exceeded $500 million in warranty claims alone. That doesn't count lost sales, advertising spent trying to rehabilitate the image, or the brand damage. And here's where the internal politics get ugly. The diesel engine was used across all GM divisions: Buick, Pontiac, Cadillac, Chevrolet. They all sold cars with this engine, but Oldsmobile bore the brunt of the blame. It was the Oldsmobile diesel. That's what people called it. That's what the lawsuits referenced. Oldsmobile's reputation took a hit it never fully recovered from. The division that had been one of GM's strongest nameplates in the 1970s became synonymous with broken promises and unreliable engineering. It's not the only reason Oldsmobile died in 2004, but it was the beginning of the end. The trust was gone. By 1985, GM killed the passenger car diesel program entirely. Done. No more diesel sedans, no more diesel wagons, no more diesel anything for the American consumer market. GM killed their diesel program. But the real legacy of the Oldsmobile diesel extends far beyond one company's balance sheet. This one engine shaped how an entire country thought about diesel cars for the next 40 years. The fallout from the Oldsmobile diesel didn't just hurt GM, it poisoned an entire technology in the minds of American consumers, and the effects lasted decades, not years. Decades. Here's what happened in Europe while America was swearing off diesel forever. European automakers, particularly in Germany and France, kept developing diesel passenger car technology through the 80s and 90s. They invested in proper fuel injection systems, turbocharging, and all the things GM should have done from the start. By the mid-90s, diesel cars in Europe were genuinely good, quiet, efficient, reliable. By 2005, roughly half of all new passenger cars sold in Western Europe were diesel. In France and Belgium, diesel market share pushed past 50%. In America that same year, below 1%, not below 10, not below 5, below 1. The gap between those two numbers is directly traceable to what happened with the Oldsmobile 350 diesel. One engine, built by one division of one company, fundamentally altered how an entire nation thought about a fuel type. No American manufacturer seriously offered a mainstream diesel passenger car from roughly 1985 to the mid-2000s. That's a 20-year gap, 2 full decades where diesel technology advanced enormously around the world, and America simply sat it out. Not because the technology didn't work, it worked fine in Europe, but because American buyers had been burned so badly that the word diesel became synonymous with broken, smoky, unreliable junk. And the stigma wasn't just personal, it was generational. People who lived through the Oldsmobile diesel nightmare told their kids, "Don't ever buy a diesel. Your uncle had one. Your neighbor had one. The dealer couldn't fix it. The engine blew at 40,000 miles. These stories got passed down like family warnings. By the time a new generation of car buyers showed up in the 90s and 2000s, they'd already been inoculated against diesel without ever having experienced it themselves. When Volkswagen brought their TDI diesels to America in the late 90s, they ran into this wall head-on. The cars were good. Modern turbo diesel technology, excellent fuel economy, solid reliability. But focus groups told a brutal story. The number one objection American consumers had to diesel cars was reliability concerns. When researchers pressed older participants on where that concern came from, they specifically referenced GM diesels from the late 70s. The Oldsmobile 350 had been out of production for 20 years at that point, and it was still killing diesel sales from the grave. The damage went beyond consumer sentiment, too. It shaped policy. U.S. emissions regulations were structured in ways that made diesel compliance significantly more difficult and expensive than European standards. The assumption baked into American regulatory thinking was that diesel was inherently dirty and problematic. The EPA wrote rules that essentially penalized diesel powertrains, creating additional barriers for any manufacturer thinking about bringing diesel passenger cars to the American market. Europe went a different direction, with regulations that acknowledged diesel's efficiency advantages and set standards that were tough but achievable. Now, think about what this cost in practical terms. Diesel engines are typically 25 to 35% more fuel efficient than equivalent gasoline engines. Over 3 decades across millions of vehicles that could have been diesel but weren't. The fuel economy benefits America missed are enormous. We're talking about millions of barrels of oil that didn't need to be consumed, billions of dollars in fuel costs that American drivers paid unnecessarily, all because one corporation decided to convert a gasoline engine into a diesel on the cheap and rush it to market without proper engineering. Now here's where the story gets really interesting. Fast forward to 2015. Volkswagen gets caught cheating on diesel emissions tests. Dieselgate. Millions of cars rigged with software to fake clean exhaust readings during testing while spewing up to 40 times the legal limit of nitrogen oxides on actual roads. It was a massive scandal everywhere. But the American reaction was uniquely severe. In Europe, diesel market share dropped from over 50% to around 30%. A significant hit. But diesel survived. In America, diesel passenger cars went from about 3% of the market to below 1% after the scandal, and it has never recovered. The thing is, Dieselgate didn't kill diesel in America. It killed diesel's second chance. The ground was already poisoned. American consumers had a 40-year-old memory baked into their collective consciousness. Diesel means unreliable. Diesel means expensive repairs. European buyers didn't carry that baggage. When Dieselgate hit, Europeans were disappointed. Americans felt vindicated. And here's the irony that really stings. Modern diesel technology is genuinely excellent. Look at American trucks. The Ford Powerstroke, the Cummins and Ram trucks, the Duramax and Chevys and GMCs. These engines are beloved. They make enormous torque. They're reliable. They last hundreds of thousands of miles. Truck buyers in America have zero problem with diesel. They actively seek it out and pay a premium for it. The technology works beautifully when it's engineered properly. The Oldsmobile proved that in reverse. Do it wrong, and you don't just lose customers. You lose an entire market segment for generations. The passenger car diesel is effectively dead in America now, and it's not coming back. Not because the technology doesn't work, but because electric vehicles have filled the niche that diesel could have occupied. The fuel efficiency argument, the torque advantage, the long-range capability. EVs offer all of that without the emissions baggage. If diesel had maintained a healthy reputation in America through the 80s and 90s, the American car market might look very different today. Diesel might have been the bridge fuel between gasoline and electric, the way it was in Europe for decades. Instead, America skipped that chapter entirely. The ghost of the Oldsmobile diesel is still shaping the cars you can buy today. Every time a manufacturer decides not to offer a diesel option in America, they're making that decision partly because of an engine that hasn't been built since 1985. So here's the thing about this whole story. The Oldsmobile diesel was never a failure of diesel technology. Diesel engines were proven. They'd been powering trucks and trains and ships reliably for decades. Mercedes had been selling diesel cars in America since the 1950s with almost no complaints. The technology worked fine. What failed was corporate decision-making. Engineers inside GM knew the block wasn't strong enough. They knew the head bolts were undersized. They knew the fuel system needed better filtration and that dealers needed proper training. They raised these concerns. Management heard them, weighed them against the timeline and the budget, and chose the timeline and the budget. Every single time. And the consequences of that choice outlived the engine by decades. Consumer trust in diesel cars was destroyed. Regulatory policy tilted entirely toward gasoline. The American auto market developed without diesel passenger cars in a way that no other major market in the world did. Europe went diesel. America didn't. And you can trace a straight line from that split back to one engine, built on the cheap rush to market to meet a deadline. But it gets more personal than that. The last Oldsmobile ever built rolled off the assembly line on April the 29th, 2004. A maroon Alero. The brand had been around since 1897, over 100 years of history. Gone. Now, there were many reasons Oldsmobile died. Shifting demographics, confused marketing, competition from within GM's own lineup. But the diesel V8 started the bleeding. It turned Oldsmobile from a brand people trusted into a brand people joked about. And some wounds just don't heal. One engine, one shortcut, 40 years of consequences, and a brand that didn't survive them. The pressure to ship fast, cut costs, and meet mandates didn't go away with the Oldsmobile diesel. It's still here. Every time an engineer gets overruled by a spreadsheet, this story is worth remembering. If you owned one of these, or your dad did, or you were the mechanic who had to fix them, drop your story in the comments. Those stories deserve to be told. And if you made it this far, subscribe. We do this every week.